Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill
T minus 7 seconds.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Hey everyone, today we are talking about sound waves and how they work. Sound is produced when something vibrates. The vibrating body causes the medium around it to vibrate. These vibrations are called longitudinal waves. These waves cannot happen in a vacuum like light waves can. Longitudinal waves have two major aspects, compression and refraction. A compression is a region of the wave where the particles are closest together. Compressions are also areas of a sound wave that have high air pressure. On the other hand, a refraction is just the opposite of compression. In fact, it is the decompression of the sound wave. Instead of the particles being closer together, they are spreading out. Refractions are also low areas of pressure in a sound wave.
Bill Nye the Science Guy.
Josh here, and I'm going to speak on resonance and its correlation with the creation of music using musical instruments. Resonance is when one object vibrating at the same natural frequency of a second object forces that second object into vibrational motion. We're going to look at this phenomenon in the specific different instrument groupings, one of which being instruments with vibrating strings, so like violins, guitars, bass guitars, open-ended column instruments, which would be like saxophones, the brass and the reed instruments. And so we're going to look specifically at saxophones. So we have this body, this tube holds in air, and here's some lips. They don't really look like lips, but that's what they are. The lips blow air into the instrument, and the lips touching the mouthpiece creates a buzz. Because of that buzz, a grouping of frequencies enters this instrument, and as we learned a few seconds ago, one of those frequencies will interact with the natural frequency, one of the natural frequencies in the air socket, in the air pocket in the saxophone. One of the frequencies from the buzz will interact with one of the natural frequencies from the air socket inside of this instrument, making the second frequency, which is the natural frequency of the saxophone, go into vibration, and that's where the sound comes from. Another more widely used instrument would be the acoustic guitar. Which is this right here. It has strings, 6 strings to be exact, and the mass of the string will decide the sound. The more massive, the lower the sound. So this is going to be my lowest string, and then the less mass, the higher the sound will be. Now you can probably guess that the sound that the guitar makes is coming from this sound hole here. It's a little more than that. The strings are vibrating, but the strings alone vibrating isn't very loud. It's the connection of the string to the bridge, to the body, where the sound can actually happen. The string transfers the frequencies to the bridge, and then the bridge transfers those to the body, and this is where the air can be, this is where the frequencies of the instrument interact with the air in this sound hole, and resonance does its thing. So The natural frequencies of this instrument will interact with the frequencies in the air, creating sound.
Bill Nye the Science Guy.
Hi! Like Professor Josh Lane, a violin makes a similar sound like a guitar in that you have strings that when plucked make vibrations, and you have a body that makes an acoustic, captures the sound and makes it louder. But the difference with the violin is that the forced vibrations take longer as you're being pulled across by one long hair. An interesting technique on the violin is called a harmonic, and that's when you take the string and you cut it in half, but you just put your finger lightly on the exact moment or exact spot on the string where the harmonic is. And it creates a clear tone, which is exactly 1 octave higher than the open string. What this is doing is essentially placing your finger and creating a node exactly halfway through so that there's a standing vibration on either side of the harmonic on the entire string.
Bill Nye the Science Guy.
Hi, I'm Morgan, and I'm going to be talking about hearing in relation to sound waves. So, first we split the ear up into 3 parts. We have the outer ear, the middle ear, and then the inner ear. We see that we have the ear flap, which is the outer ear. That is created so that it protects everything in the middle ear. The sounds enter into the outer ear, and it moves into the ear canal, which is about 2 centimeters long. After the sound wave enters into the ear canal, it hits the eardrum. Now, when it hits the eardrum is like, it's a membrane that is pulled tightly around itself. So it's this hard, almost like a trampoline-like material. And when it hits the eardrum, it creates a compression, which pushes it that way, and then it creates a rarefaction because of the compression and points back out, pushes back out, which creates a vibration. Now the vibration goes to the hammer, which makes the hammer work, and then the anvil, and then into the stirrup. Now that's the whole function of the middle ear. Now through the vibration, it is sent into the cochlea, which is this snail-like thing, which, if you pull it all the way out, is about 3 centimeters long. So a little bit longer than the ear canal. So when it goes into the cochlea, there are these little nerves in there that look like little hairs. And when it touches the hairs, it sends signals to the cochlea, and then from there, the frequencies match, and it becomes a compression wave. And once it becomes a compression wave, it is sent off by electrical impulses to the brain, which lets us know that there is sound and which frequency, pitch, and duration of the sound. Okay, so fun fact is that the ear picks up pitch by the wave frequencies that go through the ear, and the way that we interpret the loudness of sound is by the wave amplitude, so the up and down of the sound, and then how we interpret timbre is by the various wave frequencies through the ear. And that is the journey of the hearing.
Bill Nye the Science Guy.
So, now we've seen a lot of different qualities about sound and how they work. First of all, we started with Josh, and we looked at the sounds of his guitar, and we looked at the sounds of how instruments work, and how when they apply pressure on their strings, they can create a natural frequency throughout their instrument to give it that nice, beautiful music. Then we talked about Carlin, who taught us about harmonics on the string, and how applying pressure to these different strings gives you different types of tones. Then after that, we looked into what the ear actually is, and Morgan taught us a very great lesson on how the ear has refractions and compressions that hit our eardrum and then send waves up to our brain that tell us exactly what that sounds like. Now, we haven't even hardly scratched the surface on the amount of things about sound, but sound is always around us and it is ever present in our lives, so it couldn't always hurt to learn more about it. We will see you next time.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy. the Science Guy. Bill Nye the Science Guy.